This is the intro video for Algebra 1. This is section 8.2. We're going to be looking at simplifying square roots without a calculator. So let's read this statement here and fill in the blank. Radicands that are not perfect squares can be approximated with a calculator or reduced to a simpler form. So we're going to be focusing on the reduced to a simpler form here today. Last time we did look at how you could use a calculator to help. Today we're going to take the calculator away, and the way that we do that, we will use, there we go, we will use prime factors to help us reduce square roots. So the factor trees that we've done in the past will help us with this. Okay, so we're going to start off by trying to simplify square root of 12, and here's how we do it. I'm going to take the 12 and I'm going to break it apart into its prime factors. So you want to think what times what is 12. So maybe you say 2 times 6. The 2 is already prime, but the 6 is not. What times what is 6? Of course, 2 times 3. The 2 and the 3 are both prime. So again, just using a regular old factor tree like we've done in the past, what I can then do is I can rewrite square root of 12 as really the square root of 2 times 2 times 3. Square root of 2 times 2 times 3. And so then what I can do is I can look at that 2 times 2 times 3 and look for pairs of like factors. So I notice within my radicand here that I've got two 2's. I've got a pair of 2's, but I only have a single 3. So 2 times 2 is really 4, right? And so the way that we can simplify this is if I've got two 2's inside the radical, then I can take a 2 out. And so I end up with 2 times the square root of 3. The reasoning behind that, again, is that 2 times 2 is 4, and the square root of 4 is 2. So some other ways to look at this, if you prefer to look at it slightly differently, you could look at square root of 2 times 2 times 3 as the square root of 2 times 2. We'll get into this a little bit later, times square root of 3. Square root of 2 times 2 is the square root of 4, and of course the square root of 4 is 2. So 2 times the square root of 3, that would be another way to look at it. But I think the fastest way is the way that I mentioned at the start, and that is to go through your prime factored radicand and ask yourself, which numbers do I have pairs of? Which prime factors do I have a pair of? So since I had two 2's, I can bring those out, but when they come out as just a single 2. So 2 times the square root of 3. So we're going to practice this with another one here in just a second. Okay, so with this one, I encourage you to try this as much as you can. Obviously, this has a variable inside the radical. This is not going to change what we do here. We are going to break this down into prime factors. So I'm going to just focus only on the 200 for a second. So I'll write that off to the side here. 200, you could write that as maybe 2 times 100, and then the 2 is prime. And then the 100 would be 2 times 50, and again, the 2 is prime. 50 is really 2 times 25, and then 25 is 5 times 5. So those would be your prime factors of 200. So what I could then do is go back and rewrite this, and the 200 would be 2 times 2 times 2 times 5 times 5. I'm just getting that right off of my factor tree. And then the x cubed prime factors would just be times x times x times x. There's just 3 of them there. Okay, so then to start to simplify this radical, what I want to do is go through and look for pairs of like factors. So I see that I've got a pair of 2's, and so those get to come out. I've got a leftover 2 right here. That's going to have to stay. It doesn't have anything to pair up with. I also see that I've got a pair of 5's. Again, looking for pairs of like factors. So those 5's are going to get to come out. And then I've got a pair of x's right there. And it's true, kind of like the 2, I've got an extra x. That one has to stay inside the radical because it does not have a like factor to pair it with. Okay, so remember when you have a pair of 2's, they get to come out of the radical as just a single 2. So I'm going to write that right there. So that's those 2 2's that just came out. I've got 2 5's. Those get to come out as well. So it's going to be 2 times 5. And then I've got 2 x's here, so those get to come out as a single x. There is leftovers in the radical. There's this 2 right here, and there's this x right here. And so those are left over inside the radical. We might want to clean this up a little bit, of course. 2 times 5 is 10. So it's 10x times root 2x for our final simplification. Okay, when you come to class, we'll be practicing this. I'll see you then.